Hey everybody. Alright, so what I'm going to do today is probably something a lot of people in the past have done, but I haven't seen a YouTube video on this yet, so I think it's kind of important to dispel a couple of myths about the complexity of making a neutron generating fusor. It's kind of I'm just going to say it's a myth that you need to have a secondary pump, whether it be a turbomolecular type pump or a diffusion pump, in order to get the vacuum levels necessary to attain fusion within a fusor. And in this case, it's not necessary. It is necessary if you want to generate some really high numbers, but if you want to just go ahead and make some neutrons based upon a fusion reaction in a small, hint, now this is the important thing, a small chamber, in this case it's a 2.75 inch cross, it can be done. So I'm going to show you the system here real quick, and the clicks you hear in the background are neutrons being generated, and I'm going to kind of demonstrate that here in a second. So here underneath the lead shield behind the fan is a small 2.75 inch cross. I've got deuterium being fed in from the 100 milliliter syringe going into the system behind the lead plates. Currently it's at about 17 kilovolts. I'm going to ramp that up just a little bit to run the numbers up a little bit more. Deuterium pressure is about 35 millitorr, and over here on the milliamp meter I'm running just under 2 milliamps, which I'm going to bump that up to as well. And the neutron count is floating around 150 on average. I'm going to be conservative on these estimates. So my system does have a diffusion pump, but I'm going to show you that it's turned off. Diffusion pumps run at a high temperature, and I'm going to use a temperature gauge here to show you that the diffusion pump is in fact turned off. This thing should be well into the triple digits, but it's at room temperature. The pump that I'm using is a standard Ritchie Yellow Jacket HVAC type roughing pump, and that's the only thing that's feeding vacuum into the system. So let's go around over here, and all this wax is the moderator. I'm not going to go into the whole moderator way it slows neutrons. I'm just going to expect that you guys understand that at this point. So we'll go ahead and take the neutron detector out of the moderator, and that should stop any detection, because there's nothing to slow the neutrons down, and these tubes only detect slow neutrons. So we'll go ahead and put it back in the moderator, and immediately we have neutron detection again. So there's the cable going to the detector. We'll go ahead and take this out once again. Nothing. We'll put it back in, and we have neutron detection. So again, to dispel the myth, you do not need turbomolecular pumps or diffusion pumps in order to generate a fusion reaction. A lot of people have a tendency to overcomplicate, how difficult it is to put these together. If you got yourself, a good four-way cross with some good vacuum seals and a decent roughing pump, it can be done. So let's go ahead and turn the voltage up just a little bit to see if we can get a few more numbers out of this. Okay, so we're at about 20,000 volts, maybe 19 or so. I dropped it down to about 30 millitorr of deuterium. There's our star. We'll go over here again. Again, not too much. These numbers would be much higher if I had a cleaner vacuum with my diffusion pump running. And we'll go ahead and do the moderator one more time. Pull the moderator, or the tube out of the moderator, no counts. I'll put it back in. We've got count. The milliamp rating is about 2.8. And there you go.